Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on periodic properties within a period. In our last lesson, we discussed ionization potential and electron affinity as general trends in the properties of elements across a period in the periodic table. We learned that nuclear charge and atomic size are both factors that affect the ionization energy across a given period. Going from left to right, the ionization energy of elements increase in a given period. We also learned that, going from left to right across a period, electron affinity increases because of an increase in effective nuclear charge. In today's lesson, we will discuss electronegativity and metallic character as general trends across a period in the periodic table. Let us begin by learning about trends in electronegativity. I am sure you remember from previous lessons, electronegativity is the tendency of an atom to attract electrons. Electronegativity is related to both the ionization energy and the electron affinity of an atom. If we look across a given period on the periodic table, we will see that a gradual change in nuclear charge and atomic size determines the trends in the electronegativity of the elements. As we move from left to right across a given period, the electronegativity of the elements increases. Students, please choose a period in the periodic table. Then, write the electronegativity of each element in that period. You may begin.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I wonder which period you chose. Answers for this activity will vary depending on which period you used. However, this activity shows that the electronegativity of elements on the periodic table generally increase from left to right in a given period. For example, let us look at the period 4 elements. Besides a couple of exceptions, each element has a higher electronegativity than the preceding one. Elements on the left side of the periodic table have a higher tendency to form positive ions due to their low electronegativity. The elements on the right side have a higher tendency to form negative ions. Let us move on with our lesson and discuss general trends in metallic character across periods on the periodic table. I am sure that you remember that metallic character refers to the metal-like characteristics possessed by an element. Starting at the elements on the left side of the periodic table, the metallic character of each element decreases as we move right across each period. Students, why is this so? Please choose the correct answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. You were correct to say that the metallic character of each element decreases from left to right across a period, because the order of the elements from left to right across the periodic table of elements is metals, metalloids, and then nonmetals. Obviously, metals have the most metallic character, which decreases gradually through the metals, the metalloids, and then the nonmetals. Let us look at an example. This table shows the period 3 elements. They are all grouped either as metals, metalloids, or nonmetals. Sodium has the most metallic character than any element in this period. The metallic character decreases through the other metals, magnesium and aluminium. And the only metalloid in this period is silicon. Phosphorus has the most metallic character of the nonmetals in this period, down through sulfur, chlorine, and then argon. Argon has the least metallic character of any period 3 element. Students, we should also note that when we move across each period on the periodic table, the atomic size of the elements gradually decreases. Elements with higher atomic sizes have much more tendency of losing their valence electrons and forming positive ions. Thus, elements with the most metallic character are also the most electropositive. Students, let us do one last activity. This will allow you to use the information you have learned over the last few lessons about general trends in the periodic table. In a moment, you will see an image of the periodic table and a list of descriptions. Please state which element is being described by each description.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to figure out which element was being described by each description? Let us go through them together. The metalloid with the most metallic character is boron. The most electronegative element is fluorine. The most electropositive element is francium. Finally, the period 5 transition element with the lowest ionization energy is yttrium. If you are able to figure out each element, great work! If you are having some trouble, please review your notes from our previous lessons and ask teacher for some extra help. In today's lesson, we learned about 2 trends in the properties of elements across a period of the periodic table: electronegativity and metallic character. We learned that the electronegativity of elements increases as we move from left to right across a given period. We also learned that the metallic character of each element decreases as we move from left to right. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.